This is a video on potential functions. The question states, find a potential function for the vector field f of x, y, z is equal to cosine y, comma z minus x sine y, comma y minus 2z. So recall that a potential function has a property that the gradient of that potential function is equal to the vector valued function. So grad f at x, y, z is equal to cosine of y, comma z minus x sine of y, comma y minus 2z. And the gradient of a function is the vector field of partial derivatives. So I could say that the partial derivative of f with respect to x is equal to cosine of y. And the partial derivative of f with respect to y is equal to the second component, which is z minus x sine of y. And finally, the partial derivative with respect to z of f is the third component, which is y minus 2z. So now I just need to get rid of the sub x sub y sub z's to get my f. And you get rid of a partial derivative by taking a partial integral. So in other words, I integrate with respect to x. So we're thinking that y is a constant and z is a constant, and the integral of the cosine of y, or a constant, dx, is just x times the cosine of y, plus a constant. And since y and z are constants in this integral with respect to x, the constant may have y's and z's in them. So we do the same for this second component. To get rid of the partial derivative with respect to y, I integrate dy now. The integral of z is just yz, and the integral of x sine y, well, x is a constant, and the integral of sine y is negative cosine y. So the negatives cancel, and I get that f of xyz is also equal to yz plus x cosine y plus some constant, and now x and z are the constants of integration. So I have a b of x comma z. So then let's do the third partial integral to get rid of the partial derivative with respect to z. The integral of y minus 2z dz is yz minus z squared plus some constant, and now x and y are the constants, so the constant is in terms of x and y. So now I can put all of these together to collect each of the terms to find my function f, or the potential function f. So we could say that f is going to be x cosine y plus yz minus z squared. That takes care of each of the terms in all of our representations for f, and then plus some constant c. And that's a potential function for this vector field f. And I'm done with the problem.